Hey everyone, let's dive into the tiny world of atomic structures. Imagine the atom as a tiny solar system. At the center, we have the nucleus, like the sun, which contains protons and neutrons.
So, what's the deal with electrons?
Great question. Electrons, like planets, orbit around the nucleus. They move in specific regions called shells. These shells are like the layers of an onion.
And how do these shells work?
Each shell can hold only a certain number of electrons. The first shell can hold 2, the second can hold 8, and so on. These shells are named as the K, L, M, and N shells.
What about subshells?
Subshells divide these shells into smaller regions. For example, the second shell has S and P subshells. Think of them as subdivisions of neighborhoods. What's valency, you ask? Valency is like an atom's handshake. It tells you how many electrons an atom can gain, lose, or share to form a bond.
So, valence electrons?
Valence electrons are the ones in the outermost shell. They're the key players in chemical reactions.
And the valence shell?
The valence shell is the outermost shell of an atom. It's where all the action happens.
What's the octet rule?
The octet rule states that atoms are most stable when they have 8 electrons in their valence shell. It's like having a full team on a soccer field.
And the duplet rule?
The duplet rule is similar, but applies to smaller atoms. They're most stable with just 2 electrons in their valence shell.
So, in summary?
You've got the nucleus at the center, electrons in shells and subshells, valency showing bonding potential, valence electrons leading reactions, and stability rules like the octet and duplet.
That's a lot to take in.
Absolutely, but understanding these basics will make chemistry a lot easier. Now that we've uncovered the basic structure of the atom, let's dive into one of its most fascinating aspects: chemical bonds. Imagine electrons as energetic dancers at a grand ball. These dancers don't just stay with their partners, they interact with others to form bonds, creating new and exciting compounds. So, what exactly are chemical bonds? Simply put, chemical bonds are the forces that hold atoms together in molecules. There are 3 primary types: ionic, covalent, and metallic bonds. First, let's talk about ionic bonds. Picture 2 dancers, one holding a surplus of energy and the other in need of it. The one with extra energy, usually a metal, transfers some to the one in need, typically a non-metal. This transfer creates charged atoms called ions. Opposites attract, so these ions stick together, forming a strong ionic bond. Next up, we have covalent bonds. Imagine 2 dancers who decide to share their energy equally. These atoms, usually non-metals, share pairs of electrons to form a stable bond. This sharing creates a molecule, like a well-coordinated dance duo. Finally, we have metallic bonds. Picture a grand ballroom filled with dancers freely moving around. In metals, atoms release some of their electrons to form a sea of free electrons. This electron sea allows the atoms to move freely, giving metals their unique properties like conductivity and malleability. But how do these bonds affect the properties of substances? Ionic compounds, like table salt, are typically solid with high melting points. Covalent compounds, like water, can be gases, liquids, or solids with varying melting points. Metallic bonds give metals their strength and ability to conduct electricity. So, in summary, chemical bonds are the connections that hold atoms together, creating the vast array of substances we see around us. Whether through transferring, sharing, or pooling electrons, these bonds are the foundation of chemistry. Thank you for watching a deep dive into atomic structure. We hope you found this exploration of atomic structure enlightening. Don't forget to like, share, and subscribe for more deep dives into the world of science. See you next time.